In question 8a, it is given that in the expansion of 4 plus 2x into 2 minus ax to the power 5, the coefficient of x squared is minus 15. We have to find the possible values of a. Now to get a coefficient of x squared in this expansion, so 4 plus 2x will have to multiply by a term in x that will multiply by 2x to give us a term in x squared, and another term in x squared that will multiply by 4 to give us a term in x squared. So we'll have two terms, one in x squared and one in x, that will multiply by each of these terms to give us a term in x squared, and that will be equals to minus 15. Now the expansion formula for if we have an expression of the form 2 minus ax to the power 5, the formula is a power n plus nc1, a power n minus 1 b power 1 plus nc2 a power n minus 2 b power 2. Now in place of b we have ax, and as we need power x and x squared, so we can use nc1 and nc2. So using 5c1, this will become 5c1 into, now as there's a negative sign over here, so we'll have to be careful about that. In place of a, we'll write 2, and this will become 5 minus 1. And as b is minus x over here, so we'll write minus x to the power 1. So 5c1 is 5, and 2 to the power 4 will become 16. So that will become 5 into 16 into minus ax. So 5 into 16 is 80. So this will be minus 80 ax. And now for the term for x squared, we'll do 5c2. 2 to the power 5 minus 2 into minus ax to the power 2. So 5c2 in the calculator, that will be equals to 10 into 2 cube, and this will be equals to a squared x squared. The negative sign will cancel out. So 2 cube is 8, 8 times 10 is 80, so this will become 80 a squared x squared. So now we can multiply the expression. We have 4 plus 2x, and the terms for in x is minus 80x, and the term in x squared is 80 a squared x squared. Now multiplying these expressions, so this 2x will multiply by minus 80, so this will be minus 160x, and 4 will multiply by 80 to give us 320 a squared x squared, and that will be equals to minus 15, as the coefficient of x squared was minus 15. Taking x squared common on both the sides, we'll get minus 60 plus 320 a squared is equals to minus 15 x squared. We can cancel out the x squared terms and now compare the values. So we can write this as 320 a squared will be equals to minus 15 plus 160. So 320 a squared will be equals to 145. And now dividing 145 by 320, so that will be equals to, so 145 divided by 320 in fraction, that is equals to 29 upon 64. So this will be minus 15 plus 160. Okay, so there was a 160a up here. So this was 80ax, and this would have been an 80a as well. So 80 multiplied by 2 would have been 160x squared. So 160ax squared. So this would have been a as well, and we would have to add an a up here as well. So correcting this first initially, because this was an 80ax up here, so this will be minus 80ax. So writing it as minus 80ax, and now writing the expression again, so this will be equals to, so 4 into 80a squared x squared will be 320a squared x squared, and this will be minus 160a x squared equals to 15x squared. This was a minus 15. Now taking x squared common, we'll get 320a squared minus 160a is equals to minus 15x squared. So this expression will become 320a squared minus 160a plus 15 equals to 0. Factorizing this, we'll get 8a minus 3 in the calculator and 8a minus 1. So the values of a will be equals to 1 upon 8 and a will be equals to 3 upon 8. In part B, it says that it is given instead that in the expansion of 4 plus 2x and 2 minus ax to the power 5, the coefficient of x square is k. It is also given that there is only one value of a which leads to this value of k. We have to find the values of k and a. Now we already have the expansion for 2 minus ax. The two terms were minus 80ax and the x squared term was 80a squared x squared. So multiplying the expressions instead of the coefficient in this case will be equals to k. So multiplying 80 by minus 80x by 2, that will be minus 160 ax squared. 80a squared x squared with 4, that will become a 320 a squared x squared will be equals to kx squared. So taking x squared common, this will be minus 160a plus 320a squared is equals to kx squared. So the x squared terms will cancel out and we can now compare the coefficients. So this will be 160a plus 320a squared is equals to k. We can write this expression as 320a squared minus 160a minus k equals to 0. Now, as we have a quadratic expression and there is an unknown constant, we can now apply the discriminant. So this will be b squared minus 4ac and it will be equals to 0 as there is only one value of a. So the b value will be minus 160, the a value is 320 and the c value will be minus k. Now substituting this into b square minus 4ac, this will be minus 160 whole squared minus 4 into 320 into minus k equals to 0. We can rearrange this to write it as 160 whole squared is equals to 4 into 320k. Solving this, so 160 whole squared and then we'll divide it by 4 into 320. So the value of k will be equals to, so this will become a plus over here and when we take it on the other side, this will be a minus. So the value of k will be minus 20. Now once we have the value of k, now we can substitute this into the equation to find the value of a. So this expression for this, in this expression, we'll substitute the value of k. So this will become 320a squared minus 160a and k is minus 20. So this will become a plus 20 equals to 0. Dividing the expression by 20, we will get, so this will be 16a squared minus 8a plus 1 equals to 0. We can write it as 16a squared minus 4a plus 1 equals to 0. Taking 4a common, we will get 4a minus 1 and taking 1 common, we'll get 4a minus 1 up here. Simplifying, we'll get 4a minus 1 and 4a minus 1. So the value of a in both cases will be a will be equals to 1 upon 4.